going to talk about central and inscribed angles today, so we need to define what a central angle is, and then we'll just define what an inscribed angle is. And a central angle is an angle that has its vertex at the center of the circle. So in this, and extends to the edge of the circle, its measure is equal to the measure of the intercepted arc. So first of all, we need to know what is an intercepted arc. And although I cannot possibly highlight this, but the intercepted arc is that value from A to B and that arc right there. And the measure of the intercepted arc is the same as the measure of the intercepted angle. You notice angle C has a value of 73 and arc AB has a measure of 73. So central angle equals the intercepted arc. Again, angle ACB is the central angle, and arc AB is the intercepted arc. Central angle, same as the intercepted arc. The other type of angle that we're going to look at today is an inscribed angle. And an inscribed angle has the vertex on the circle, and what I say in the definition is on the edge of this circle, extending inward to the opposite edge of the circle. And once again, I want to point out, even though it's very hard for me to draw it in, this arc between A and B, that's the intercepted arc. And because it's less than 180 degrees in this case, arc AB, we name a minor arc with 2 points, is the intercepted arc. Angle C, or angle ACB, is the inscribed angle. Again, inscribed angle has the vertex on the circle. Central angle has the vertex at the center. So central and center go together. The rule that I'll probably say many, many times today is that the measure of the inscribed angle is equal to half the measure of the intercepted arc. So if you notice here, if we take 146 and we divide it by 2, we end up with 73. The measure of the inscribed angle is half the measure of the intercepted arc. So now that we know a little bit about both of those, then we're going to try a few examples to practice. And it says, first determine if the indicated angle is a central angle or an inscribed angle. Then find the value of x. So if we look at letter A, well, letter A has the vertex at the center of the circle. And again, center and central go together. And then the relationship between the center, or the central angle, and the intercepted arc is that they have the same measure. So the intercepted arc is 35 degrees, which means that x is also 35 degrees. Letter B, we want to find the value of x. Angle ABC is our inscribed angle. It's an inscribed angle because the vertex is on the circle. So this is an inscribed angle. And the relationship here, AC, arc AC is the intercepted arc. The relationship is that the inscribed angle is half the measure of the intercepted arc. So 1/2 of 44 is 22. Central angle, same. Intercepted angle, no, let's say it better. Inscribed angle is half the intercepted arc. if we look at letter C here, see if you can pick yourself what it is in 10 seconds before I fill it in. And what we see is that angle LKJ is on the circle, which means that it is an inscribed angle. And once again, the measure of the inscribed angle is half the measure of the intersected arc. So this value right here is half the measure of this value right there. So if we want to figure out what that value is, we're going to take 2 times 96 to figure out that value of x. 2 times 6 is 12, 2 times 9 is 18, 19. Gives us 192 degrees. And finally here on letter D in this example, we have an angle at the center of the circle, and because it's at the center of the circle, it is a central angle. And once again, what we know is that the measure of the central angle is the same measure as the measure of the intersected arc, which is that arc GI, and it is going to have a value of 139 degrees. Example 3. Find the measure of each of the following arcs or angles. So our first one here is arc BD, but if we look real close at this, we have a central angle here where I just put that blue mark in. And since it's a central angle, and what we're given that angle is 32 degrees. It's a central angle. That means that arc BC is also 32 degrees. But ultimately what we're trying to figure out is, well, what is arc BD? So we need to find the measure from here to here. But now that we know both of those arcs, we can take 32 plus 58. And when we add those two together, we get 90. So arc BD is 90 degrees. Well, arc ABC is our next value. The one thing that I kind of omitted in the directions that I need to add is that we're dealing with, how about I spell it right, circle O. O is the center of the circle, which means that this length of CA is the diameter of the circle. It's the chord that extends through the center to either end of the circle. So if CD is 58, we can figure out this value of DA because a semicircle has 180 degrees in it. And if we subtract 58 from that, we'll get the measure of, let's see, what do we have to find? A, B, C. We'll get a measure that's going to help us, I think, to figure this out. 10 minus 8 is 2, and 7 minus 5 is 2. So this is 122. I don't know if I can write it in or not. Not so you can see it. Try one more time. 122. Again, what we're trying to find is we're trying to find A, B, C. And I went the wrong direction, but eventually we're going to need to know the 122. Same idea over here on the other side. I'll switch to red here. We can find this length here in red. Once again, because this length right here is the diameter of the circle. So it cuts the circle in half, and we've got 180 degrees. So if we take 180 degrees minus 32, 10 minus 2 is 8, and 7 minus 3 is 4. That gives us 148 degrees. And now we know everything, in terms of the arcs at least, so we can figure out our values. And in fact, if we look at letter C, it says arc AB. Well, that's what we just found. It's 148. if we go back and figure out, well, what's arc ABC? Well, ABC, I made that harder than it needed to be, is a diameter, or it comes from the arc that intercepts the diameter, so it's going to be 180 degrees. Arc DAB, now that we've filled in everything in the circle, arc DAB, well, DAB, we can add up what we need to add up here. Arc DA is 122. Arc AB is 148. It's going to be a major arc, as we see, but when we add these two together, say it is 10, 7, 270. Angle, DOA, this time. We need to find a better color here. We'll try the pink. Angle DOA. There's our angle. But angle DOA is a central angle. And the measure of a central angle is the same as the measure of the intercepted arc. So we know that the intercepted arc is the 122 degrees, which means that the central angle here is also 122 degrees. And finally, angle BOD, let's see where that is, angle BOD is that one, and that's going to intercept this angle, sorry, that arc right there, that intercepted arc of BD, which is the first value that we found. And arc BD has a total of 90 degrees because there's the 32 plus the 58, and the measure of the central angle is the same value as the measure of the intercepted arc. So angle BD is also 90 degrees. As we get close to finishing, in our last example, it says if the measure of arc BC is 34 degrees, we want to find the measure of the missing angle. So we've got to figure out, well, what's angle 1, what's angle 2, what's angle 3. And in fact, the easiest angle to start with is angle 3. Because angle 3 is at the center of the circle, so angle 3 is a central angle, and the measure of angle 3 then is the same as the measure of the intercepted arc. It's 34. Well, to find measure of angle 1, measure of angle 1 has its vertex on the circle. That means it's an inscribed angle. And the rule for the inscribed angle is that that value is half the measure of the intercepted arc. Well, the intercepted arc is the value of BC. So if we want to know our angle, we're going to take half the measure of 34, and half the measure of 34 is 17. So we know two values here, and in fact I'm going to erase a little bit and to finish up with angle 2. But what we know here is, we know that measure of angle 3 is 34. We know that measure of angle 1 is 17. Wrong color. And if we're really looking closely on this one, what I hope that you recognize is that the triangle in this problem, this triangle, is an isosceles triangle. And one of the ways that I know it's an isosceles triangle is because MB is a radius of the circle, and MA is a radius of the circle. So that means that this length is the same as that length. And we have an old rule to refresh our memory with. And it is that angles across congruent sides are congruent. So we can also identify the measure of angle 2. And it is also 17 degrees.